Hello and welcome, dear listener. Tonight we're diving into one of the most mysterious and deepest places on Earth, the Mariana Trench, a world so dark and remote few have ever seen it, but strange and beautiful creatures call it home. As we descend slowly into the deep, take a moment to breathe, relax, and let your imagination drift. And before we begin, tell me in the comments, where in the world are you listening from? Whether you're by the sea, in a busy city, or tucked into a cozy bed, I'm so glad you're here. Now, let's begin our journey, deeper and deeper into the quiet blue. Far above us, the sun glows warmly over the rippling waves. The surface of the ocean dances with light, glittering like 1,000 tiny stars. Seabirds call in the distance, and the wind hums gently across the open sea. But we are not staying up here. No, we are going somewhere far deeper, far quieter. We begin our descent. At first, it feels like a gentle slide, like sinking slowly into a warm bath. Light filters through the water in soft, shimmery rays, painting everything in hues of turquoise and blue. Fish flicker around us, their silver scales catching the sun like pieces of polished glass. Coral reefs and schools of colourful life fill the upper ocean like a crowded city, alive and moving. But we are only just beginning. As we drift downward, the colours start to fade. Red disappears first, vanishing into the water around us, followed by orange, yellow, and green. The water darkens to a deep, endless blue. The sunlight above becomes a memory, growing weaker and more distant with every passing metre. The water cools, the world becomes stiller. We pass through the twilight zone, a strange, silent region where sunlight barely reaches. The fish here are different, long, sleek and quiet. Some have wide, staring eyes adapted for the faintest glimmer of light. Others carry their own glow like soft lanterns drifting in the water. It feels peaceful here, timeless, as though we've left behind the human world entirely. Down we go. Now we're passing 1,000 metres, deeper than any human diver can safely travel. The pressure increases, but you don't feel it. Here, in our safe vessel of imagination, you're weightless, floating, relaxed. There is no sound except for the slow, rhythmic pulse of the sea. No urgency, no stress, just the quiet, the dark, and the occasional shimmer of something moving far in the distance. We pass through the midnight zone, where total darkness reigns and the temperature drops even more. The creatures here are rarely seen. Some flash with bioluminescence, others hang silently in the water like ancient spirits. Their shapes are unfamiliar. Long fins, strange mouths, glowing lures, or completely transparent bodies, each one perfectly designed to survive in this quiet, forgotten world. Still, we sink. We are now thousands of meters beneath the waves. The ocean above us is a thick blanket of pressure, lightless and vast. And yet, life continues. Around us, the water is filled with tiny particles drifting down from the upper ocean. The slow, steady fall of marine snow, organic matter, flakes of dead plankton, fragments of plants and animals gently feeding the depths. It's almost like snowfall in a black sky. The silence here is not empty, it is full of mystery. A sacred kind of quiet that only exists when you are completely removed from the surface world. There are no cities here, no noise, no clocks, only stillness and time moving at its own ancient pace. Finally we approach the Hadal Zone, the deepest part of the ocean, where the Mariana Trench yawns wide beneath us like a great silent canyon. The pressure is immense, the darkness complete. And yet, as we drift closer to the ocean floor, a strange and beautiful world begins to appear. Not barren, not lifeless, but full of creatures most humans have never seen, fragile, glowing, otherworldly. And now, as we float above this abyssal kingdom, we are ready to meet them, one by one. Let us begin. The Mariana Trench is not just a place, it is a secret, hidden deep beneath the Pacific Ocean, in a part of the world most of us will never visit, and few have truly seen. If the earth were to whisper its oldest, quietest story, they would echo from within this trench. Stretching over 1,500 miles long, and plunging to a depth of nearly 11,000 metres, the Mariana Trench is the deepest natural point in the Earth's crust. It lies east of the Mariana Islands, near Guam, far from the hustle and noise of human life. Here the seafloor folds in on itself, forming a vast crescent-shaped scar in the ocean that reaches deeper than Mount Everest is tall. To imagine the trench, close your eyes and picture standing at the edge of a vast canyon. But instead of being carved by wind or river, it's been slowly shaped by the slow grinding of tectonic plates beneath the sea. The Pacific Plate, one of the Earth's great moving slabs of crust, is being pushed underneath the smaller Mariana Plate. This process, called subduction, is what formed the trench, a geological sigh in the deep ocean, where one piece of the Earth slips beneath another, inch by inch, over millions of years. The trench is not just deep, it is ancient, and it is unlike anything else on Earth. If you were to travel to the Challenger Deep, the very deepest part of the trench, you'd be 10,184 metres below sea level. That's almost 36,000 feet. For comparison, if you drop Mount Everest into the trench, its summit would still be more than a mile underwater. It's a place so extreme that for a long time scientists believed it couldn't possibly support life. The pressure down there is over 1,000 times greater than what we experience at sea level. Imagine the weight of 50 jumbo jets pressing down on your body all at once. It is completely dark. Temperatures hover near freezing, and yet even here, life endures. Because of its remoteness, the Mariana Trench remained a mystery for much of human history. In fact, no human reached the bottom until 1960, when Swiss oceanographer Jacques Piccard and US Navy Lieutenant Don Walsh made the journey in a small steel submersible called the Trieste. It took them nearly 5 hours to reach the bottom, and when they did, they could barely see anything through the silt that had been stirred up. But what they did see was shocking. Life. A flatfish, maybe a type of sole or flounder, slowly gliding along the sea floor. It was a discovery that changed everything. The deep was not lifeless. It was simply waiting to be seen. Since then, very few missions have returned to the trench. In 2012, filmmaker and explorer James Cameron descended solo to the Challenger Deep in a specially designed submersible. He described the landscape as alien, silent and moon-like, covered in fine silt and scattered rocks. But even there he found signs of life. Tiny amphipods, sea cucumbers, and strange translucent creatures moving gently through the water. It was a reminder that even in the most extreme conditions, life finds a way. Today we know that the Mariana Trench is not empty. It is alive with mystery. Microbes thrive in the rocks. Crustaceans scuttle across the seabed. Jelly-like organisms float through the pitch black. Many of these creatures have never been seen anywhere else on Earth, and some may still be completely unknown to science. There are no coral reefs down here, no colourful fish darting between rocks, no sunlight. Instead, this is a world of adaptations, creatures that glow in the dark, animals with no eyes, bodies built to withstand unimaginable pressure, mouths that open wide to eat whatever food may drift by. It's a place that defies everything we think we know about life. The trench also holds clues to Earth's distant past. Sediment settles here from across the ocean, layer upon a layer, over thousands of years. Scientists have even found plastic in its depths, a haunting reminder that even the most remote places are not untouched by humanity. But in the midst of this, the Mariana Trench remains a refuge for the strange and the forgotten, a hidden world beyond the reach of sunlight and time. As we float gently above it now, imagine the quiet, the darkness, the weight of the water pressing from above, the cold silence wrapping around everything. And somewhere down below, something stirs, something ancient and small, living its quiet life in the shadows. The trench is not empty, it is simply waiting to be known, and tonight we will begin to know it, creature by creature, glow by glow, dream by dream. In the deepest parts of the ocean where no sunlight has ever reached, life finds a way to continue, quietly, mysteriously and beautifully. It is a realm so alien from the surface world that it might as well be another planet. Yet down here, in the crushing dark, in temperatures near freezing, with no plants, no sunlight, and very little food, life not only exists but thrives in strange and wondrous forms. The rules of life in the deep sea are different. On the surface, life depends on light. Plants need it to grow, and animals need plants, either directly or indirectly, for energy. But in the Haddle Zone, the region of the ocean deeper than 6,000 meters, there is no light at all. The sun's rays do not reach beyond a few hundred meters, and by the time we descend into the trench, we have left behind the world of photosynthesis completely. Here, instead of green plants, life depends on a slow, steady rain of dead material falling from the surface. Something scientists poetically call marine snow. It is made of the remains of plankton, tiny bits of fecal matter, dead jellyfish, and fragments of plants and animals. As it drifts down, it becomes the primary source of food for the trench dwellers. A gentle snowfall of life-giving dust, sinking ever downward through the darkness. It is this slow, delicate stream of organic matter that sustains much of the ecosystem in the trench, a world that waits in patience for each flake to fall. But marine snow is scarce, and it grows thinner the deeper you go. So the creatures of the Mariana Trench have learned to adapt in astonishing ways. Some, like the ghostly snailfish, have paper-thin bones and jelly-like flesh that help them survive the intense pressure. Others, like amphipods and deep-sea cucumbers, act like scavengers, cleaning the seafloor of anything that drifts down from above. Nothing is wasted here. Every scrap matters. Some life forms in the trench do not rely on marine snow at all. Instead, they turn to chemicals. Near the trench's base, scientists have discovered tiny microbial communities that feed not on sunlight or falling debris, but on hydrogen and methane that seep from the rocks below. These are called chemosynthetic organisms, life forms that use chemical reactions to make their own energy. On the ocean floor, in deep cracks and hydrothermal vents, these microbes form the base of an invisible food chain, quietly powering ecosystems without a single beam of light. It's hard to imagine what it feels like to live down here. The pressure is immense, over 1,000 times what we experience at sea level. A human being would be crushed instantly. But deep-sea creatures don't have air-filled lungs or delicate bones like we do. Instead, their bodies are soft, flexible, and filled with water, which cannot be compressed. It's as if the ocean made them from the very fabric of the deep, shaped them to endure and belong, and what of movement? There is no rush in the trench, no need to hurry. The animals here drift slowly. They conserve energy. They don't chase prey in bursts of speed like predators in the upper ocean. Instead, they float silently, sensing vibrations, following faint smells in the water, or lying still for hours, or even days, waiting for the food to come to them. Many trench creatures have lost their eyesight completely. After all, why have eyes where there is no light? Others have evolved giant ultra-sensitive eyes to detect the faintest traces of bioluminescence, the cold glowing light produced by some deep-sea animals, a gentle pulse, a flicker, a slow-moving shimmer in the distance. Down here, light is rare and precious. It is both lure and warning. It can attract prey or confuse predators. Some creatures carry glowing patches on their skin. Others flash patterns like silent signals in the dark, and some, like the anglerfish, dangle glowing bait in front of toothy mouths, using beauty to draw others in. Each creature is adapted not just to survive, but to thrive in its own quiet way. They are not weak. They are not leftovers. They are the result of millions of years of evolution in the most extreme conditions on Earth. The deep sea doesn't demand speed. It doesn't reward size or strength. It asks for patience, stillness, silence. It favours the strange, the soft, the careful. Down here, life whispers instead of roars. And yet, even in this silence, there is rhythm. Currents move, sediments settle, creatures glide. The ocean pulses with a slow, ancient heartbeat. It has always been this way, long before humans built cities, before ships crossed the surface, before satellites blinked overhead. The life in the Mariana Trench is not new. It is old, ancient, sacred in its stillness. To most people, the deep sea seems empty, but the truth is, it is simply hidden, waiting, watching, existing quietly beyond the reach of sunlight. A gentle reminder that life does not need to be loud to be powerful, that even in the darkest places, wonder endures. In the deepest known part of the ocean, there lives a creature so delicate, so ghostly, and so quietly extraordinary that its very existence defies everything we thought we knew about life under pressure. This is the Hadal snailfish, a soft-bodied, translucent animal that makes its home more than 8,000 meters below the ocean surface, in the crushing blackness of the Mariana Trench. Imagine for a moment a fish without scales. Its body appears almost see-through, like a ribbon of gelatin floating through ink. Its skin is pale, nearly colourless, with hints of soft pink or milky white. Its bones are not rigid like those of most fish, but fragile, thin and partially cartilaginous. If you were to see it on the surface, it would look too delicate to even exist. And yet, in the depths of the trench, it is perfectly at home. The Hadal snailfish, a member of the genus Pseudopolyporus, holds the record for the deepest living fish ever observed. In 2022, scientists captured footage of one gliding peacefully at a depth of over 8 meters. That's more than 5 miles beneath the sea. Down there, the pressure is more than 800 times greater than the air pressure you feel right now. To a human, that would be instantly fatal. To the snailfish, it's just another quiet day. But how does it survive? The key lies in its body. Unlike most fish, the Hadal snailfish has no swim bladder, the gas-filled organ that helps fish control their buoyancy. Gas compresses easily, and under extreme pressure, it becomes a liability. So the snailfish has done away with it entirely. Instead, it uses the gentle composition of its gelatinous body to maintain its position in the water. It doesn't fight the pressure, it flows with it. Inside its cells, the snailfish contains high concentrations of a special chemical called TMAO, trimethylamine N-oxide. This compound helps protect its proteins from the damaging effects of pressure. The deeper a snailfish lives, the more TMAO it produces. It is nature's own pressure shield, built into the fabric of the creature itself. Its bones are thin and spongy, some barely more than whispers of calcium. On land, this would make it fragile, but in the deep ocean, it is an elegant solution, where others must be armoured. The snailfish is supple, flexible, built not for resistance, but for grace in the deep. Its face is gentle, Small eyes, unnecessary in the dark, sit above a rounded mouth. It feeds mostly on amphipods and tiny crustaceans that drift across the seafloor or hover just above it. The snailfish does not chase, does not lunge. It glides slowly, sensing movement, picking its moments with patience. There is no rush. In the deep, everything happens in its own time, and while it may seem like a lonely life, it is not alone. In some places within the trench, multiple snailfish have been observed together, floating in ghostly schools, their pale forms drifting silently side by side. Scientists have even seen juveniles higher in the water column, slowly descending as they mature. It suggests a quiet community, moving gently through the darkness like spirits of the sea. The discovery of the Hadal snailfish astonished scientists. Before they were filmed and later caught in special pressure-retaining traps, many experts believed fish could not survive beyond 8,000 meters. It was thought the proteins in their cells would stop functioning, or that their bodies would collapse. But the snailfish proved otherwise. It is a living exception, a soft rebellion against our assumptions. Even in death, it tells a story. When scientists bring them to the surface, they often don't survive. Their delicate bodies, built for pressure, collapse or dissolve as they rise. This has made studying them incredibly difficult. Much of what we know comes from deep-sea cameras and remote submersibles that observe them from afar. They are creatures best left in their quiet world, undisturbed, unhurried, unknown. Their presence is a gentle reminder that life can take many forms. It does not need armor or aggression to endure. Sometimes, softness is strength. In the trench, the most extreme place on Earth, a fragile, glowing ribbon of a fish floats peacefully through the silence, defying logic with every beat of its heart. We think of survival as something loud, fierce, but the snailfish teaches us that true resilience can also be turbulent, invisible, gentle. Down here in the Hadal depths, where the world is black and the weight of the ocean presses from every direction, the snailfish moves with quiet purpose. It is not merely surviving, it is thriving, and as we drift beside it now through this silent cathedral of water, we are reminded that even in the coldest, darkest places imaginable, there is beauty, there is life, and there is peace. Floating in the black silence of the Mariana Trench are some of the ocean's smallest scavengers, creatures that would barely be noticed in shallower waters, but in the deep, they play an essential role in the survival of life. These are amphipods, tiny shrimp-like crustaceans with translucent bodies, curved backs, and long, delicate antennae. They may not look impressive at first glance, but they are marvels of adaptation, thriving where few others can. Amphipods are often the first to arrive when something falls from above. A fish carcass, a jellyfish, or even human debris, they are the trench's quiet recyclers, patiently breaking down what the sea delivers. They live in the pitch black, where pressure could crush steel and food is a rare treasure. And yet here they are, busy, purposeful, and elegant in their simplicity. In the Hadal zone, amphipods are found in astonishing numbers. Some species can be seen swimming gracefully through the water column. Others scurry across the silty bottom like silent janitors of the deep. Their bodies are semi-transparent, as if made of glass or moonlight. Their exoskeletons, unlike the hard armoured shells of surface-dwelling crustaceans, are thinner and more flexible, an adaptation to the crushing depths in which they live. But what truly sets deep-sea amphipods apart is their size. In the surface ocean, amphipods are typically very small, often no more than a few millimeters long. But in the trench, they can grow to the size of a human hand. This phenomenon is known as deep-sea gigantism. In the cold, dark depths, some species take on exaggerated forms, perhaps to conserve energy, store food, or move more efficiently in the slow currents of the abyss. One such species, Alicella gigantea, has been found at extreme depths and can measure up to 30 centimeters, enormous by amphipod standards. With its long legs, curved tail, and oversized antennae, it resembles a creature from another world. It drifts slowly, like a dream unfolding in slow motion, its limbs moving with deliberate grace. Amphipods feed on whatever they can find. They are not picky. Bits of fish, plankton, and organic detritus all serve as nourishment. In the trench, a single dead animal falling from the upper ocean can become a feast, not just for one amphipod, but for a whole community. They gather quickly, swarming in silence, working together without thought or command. Their tiny mouths pick apart the remains, turning what once lived into something new. In this way, they keep the deep ocean alive. Some amphipods are equipped with special sensory hairs that help them detect chemical changes in the water, the faint scent of decay, the distant presence of food. Others are tuned to vibrations, sensing movement in the water that may indicate a falling body or a nearby predator. Without light, these creatures rely on touch, taste, and instinct, a kind of deep, ancient intelligence built not on thought, but on feeling. Their lives are quiet, but not uneventful. They are hunted by larger creatures, snailfish, cusk eels, and other abyssal dwellers that rely on amphipods as a food source. But the amphipods do not run. They drift, they glide, they wait. In a place where speed is rarely needed, patience is the true skill. Scientists have studied amphipods not only for what they do, but for what they can survive. Samples taken from the trench have revealed that these tiny crustaceans can tolerate extreme pressure, near freezing temperatures, and complete darkness for their entire lives. Some amphipods even appear to survive in chemical-rich environments near hydrothermal vents, or in the sediment of Hadal trenches, where few other animals can exist. And there is more. In 2017, scientists discovered something unsettling inside trench-dwelling amphipods, tiny fragments of plastic. Even in one of the most remote places on Earth, these creatures had consumed microplastics, evidence of the far reach of human impact. It was a sobering discovery. The amphipods unknowingly had become messengers. Their translucent bodies told a story of resilience, but also of vulnerability, a silent call to protect the invisible world we so easily forget. Still, the amphipods endure, quiet, tireless, and essential. They are part of a delicate chain that keeps the ocean's deepest ecosystem functioning. Without them, the trench would fill with the detritus of decay. But because of them, life is recycled. Energy is passed on, the great cycle continues. To watch an amphipod move is to see a kind of underwater poetry. Its many legs ripple like strands of silk. Its body pulses gently with each motion. It does not race or struggle, it simply exists, gently, persistently, fully. In the deep ocean, there are no grand battles, no bright flashes or crashing waves. There are only creatures like the amphipod, living quietly at the bottom of the world, reminding us that Ishren can be stormed, and that even the smallest life has a place in the great mystery of the sea. So the next time you think of the deep ocean as empty, remember the amphipod, a tiny glowing worker of the dark, gliding through the shadows, keeping the quiet heart of the earth beating. In the silent depths of the Mariana Trench, where even the faintest flicker of sunlight has long vanished, lives a fish so strange and subtle that it seems pulled from the pages of a dream, the cusk eel. Despite its name, the cusk eel is not truly an eel. It is a fish, a member of the order Fidiformes, with a body shaped like a ribbon, long and slender, undulating slowly through the water like smoke in still air. The cusk eel's form is perfect for life in the deep. Its body tapers smoothly from head to tail, allowing it to glide without resistance through the heavy blackness of the abyss. Its fins are fused into one continuous line that runs along its back and belly, creating a gentle wave that moves it forward in slow, sinuous curves. There is no hurry in the trench. The cusk eel moves with patience like a drifting whisper, responding not to sight or light, but to the subtle tremors of life around it. Its skin is soft and smooth, often a pale, silvery colour, though some species appear almost translucent, as though they are made of water and shadow. In some, the scales are so small they seem to vanish completely. Their eyes, reduced in some species to little more than dark orbs, are sometimes vestigial, unnecessary in a place where light does not exist. Others have large ghostly eyes, adapted not to light, but to bioluminescence, that rare and wondrous glow produced by life itself in the deep sea. But the most mysterious part of the cusk eel's story lies not only in how it looks, but how it lives. These fish dwell on or near the seafloor, in the soft, silty sediment that blankets the trench like powder. They often burrow into the mud or hide among rocky crevices and mineral outcroppings. In the abyss, there are no coral reefs, no kelp forests, no bustling communities like in shallower waters. Instead, there are pockets of stillness, quiet folds in the landscape where a fish like the cusk eel can settle, wait and watch. Its feeding habits are as unhurried as its movements. The cusk eel is an opportunist. It feeds on small crustaceans, worms, amphipods, and whatever other organic material drifts within reach. Some lie motionless for long periods, hidden in the silt with only their eyes and nostrils visible, waiting for vibrations to signal the presence of prey. Others drift just above the bottom, following the scent trails of food through the pitch black. Its jaws are surprisingly powerful. Some species possess a hinged skull and specialized muscles that allow them to open their mouths wide, creating a vacuum that sucks in prey with sudden force. In the trench, where meals may be days or even weeks apart, every opportunity to eat must be seized with care and precision. And yet, for all its predatory capabilities, the cusk eel is not a terror of the deep. It is a quiet hunter. More shadow than shape, more presence than predator. Its long body allows it to maneuver gracefully in tight spaces and rocky crevices, where few others can follow. In this way, it avoids both predators and competition, slipping through the underwater landscape like a thought unspoken. Their life cycles are equally mysterious. Much of their reproduction takes place in the hidden dark, far from any observer's eyes. Some species are believed to release eggs into the water column, where they float upwards, carried gently by the currents. The larvae develop in the slightly shallower waters, where food may be more abundant and survival more likely. As they grow, they slowly descend, returning to the world of their ancestors, the bottomless depths of the trench, where they will live out their silent lives. Some cusk eels have been found in the Hadal zone, over 6,000 meters deep. Others thrive slightly higher, in the abyssal plains. But all share one thing in common: the ability to exist in a world that appears, to us, nearly impossible. A place where the water is cold, the pressure is crushing, and yet, somehow, life flows on. To spot a cusk eel with a submersible camera is a moment of quiet awe. Its body moves in lazy coils, unbothered by the bright lights of human observation. It doesn't dart away or panic. It simply continues on its path, undeterred. For millions of years, its ancestors swam these same dark waters, untouched by human hands. And now, just for a moment, we glimpse its world. Some scientists believe that cusk eels may play a vital role in the Hadal ecosystem, helping to recycle nutrients, control populations of smaller animals, and even serve as prey for larger predators like deep-dwelling sharks or snailfish. But there is still so much we don't know. Every time we explore the trench, we learn something new, a different species, a new behavior, an unexpected adaptation. The cusk eel is part of that unfolding story, that quiet catalogue of secrets the ocean still holds. It reminds us that life is not always loud. It doesn't always flash or roar. Sometimes life is soft, long-bodied, pale and watchful, drifting slowly over a world untouched by time. The cusk eel is a quiet sentinel of the deep, a creature of elegance, patience, and quiet strength. And in its sadness it speaks volumes. In the deep sea where no sunlight can penetrate and darkness stretches endlessly in every direction, a miracle happens. Life creates its own light. This gentle, otherworldly glow is called bioluminescence. A soft shimmer, a pulse, a flicker in the blackness that seems to come from nowhere. It is one of nature's most elegant adaptations, and in the trench where shadows reign and silence dominates, it becomes not just useful, but essential for survival. Bioluminescence is not just rare trickery, it is a form of communication, a way to see and be seen, a subtle language spoken through light. In the Mariana Trench, where pressure would crush steel and the cold can freeze bones, light is currency, it is bait, it is camouflage, and for the creatures of the trench, it is as vital as wings are to birds or gills are to fish. But what exactly is bioluminescence? At its core, bioluminescence is a chemical reaction. Within special light-producing organs called photophores, certain molecules react with oxygen to create cold blue-green light. This light doesn't generate heat, which is important, because in the fragile, tightly balanced environment of the deep, even a little excess warmth could be dangerous. Instead, the light glows softly, like a lantern flickering in the dark, visible only to those with the eyes to see it. Many deep-sea animals can produce this light on their own. Others rely on symbiotic relationships with glowing bacteria, hosting them in specialized parts of their bodies in exchange for a constant radiant glow. This partnership between fish and microbes is one of the most remarkable examples of biological harmony. A peaceful coexistence in the loneliest parts of the world. The functions of bioluminescence are as varied as the creatures that use it. Some fish use it to lure prey, like the infamous anglerfish, which dangles a glowing bulb in front of its mouth like a baited hook. Curious animals swim toward the light, only to find themselves swallowed in an instant. In this world where finding food is rare and difficult, trickery becomes a vital hunting tool. Other creatures use bioluminescence to confuse predators. Some release bursts of light into the water, startling an attacker just long enough to escape. Others flash glowing patterns along their bodies, mimicking the flickers of distant animals or breaking up their own silhouettes so they disappear into the background. And then there is counter-illumination, one of the most ingenious uses of light in the deep. In the upper twilight zone just above the trench, some fish produce light on their bellies that perfectly matches the faint sunlight filtering down from above. This makes them invisible when viewed from below. In a place where predators often look upward, searching for shadows, these glowing bellies erase their outlines completely, allowing the fish to glide unseen. For some animals, bioluminescence is a form of communication. Tiny pulses of light may act as mating signals, drawing partners together across the empty water. Others may flash warnings to intruders, marking territory with a light only their own species can interpret. Even in the silence of the trench where no sound can travel far, the sea has found a way to speak. There are bioluminescent jellyfish with long trailing tentacles that ripple with shifting colour as they float. There are shrimp that spit glowing clouds into the water, creating a veil of stars behind them as they flee. Some worms and small planktonic creatures create entire light shows, glowing green or blue, flickering in rhythms, sometimes even spiralling like underwater fireworks. And the beauty of it all, the light is slow, it pulses gently without urgency. It glows like breath, in and out, like a heartbeat slowed by peace, It does not rush or flash wildly unless threatened. In the deep sea, everything is measured, graceful and quiet. Even the light obeys this rhythm. Scientists exploring the Mariana Trench with deep-diving submersibles have described these glowing displays as the most hauntingly beautiful things they've ever seen. In the complete darkness, where no other colour survives, these living lanterns shine. Sometimes the submersible lights are turned off entirely, and what's left is a field of blue dots, drifting, winking, sparkling like the stars. Only here the stars are alive. They swim. They move with intent. They are part of a world we are only beginning to understand. What makes bioluminescence even more remarkable is that so many of its forms remain unknown to science. Every dive into the trench reveals new flashes, new shapes, new flickers. Creatures we've never seen. Signals we cannot yet interpret. It is a living language with 1,000 dialects, one we are slowly learning to hear. And then, of course, there is the simple beauty of it. To see a glowing creature glide past in the depths, unbothered by our gaze, unaware of its own strangeness, is to witness something sacred. It is as if the ocean is telling us softly, so even here, in the deepest silence, light remains. Life remains. In the world above, we often forget how powerful light can be. We're surrounded by it, day and night, in the sun, in our screens, in the buzz of cities. But down here in the trench, light is precious. It must be made, it must be chosen. Every glow is intentional, every flicker has meaning. The creatures of the trench don't need sunlight. They carry their own, softly, gently, quietly. And in that glowing darkness, they remind us that even in the most forgotten corners of the earth, wonder still lives. In the crushing blackness of the deep sea, hidden within the endless folds of the Mariana Trench, swims one of the most haunting and otherworldly creatures ever discovered, the dragonfish. It is a name that conjures images of mythology and fire-breathing beasts, and in some ways the dragonfish lives up to that legend. Not in size or roar, but in mystery, elegance, and the quiet terror of its appearance. The dragonfish is slender, serpentine, and often barely longer than your hand. But what it lacks in size, it makes up for in power and precision. Its body is long and muscular, adapted for sudden bursts of speed in a world where food is scarce, and survival depends on both patience and ferocity. Draped in deep black or dark bronze scales that shimmer faintly when illuminated, it is nearly invisible in the dark, a perfect predator wrapped in shadow. But perhaps its most striking feature is its mouth. When open, the dragonfish reveals a set of long, needle-like fangs so large they can extend outside of its mouth when closed. These translucent teeth are not just terrifying in appearance, they're incredibly effective. Razor-sharp and curved, they are designed to grasp and trap slippery prey, holding them fast as the dragonfish swallows them whole. And unlike most fish, the dragonfish's jaw is hinged in such a way that it can open extraordinarily wide, allowing it to consume animals nearly as large as itself in a single gulp. This is a necessity in the trench, where meals may come once a week or even once a month. Every opportunity must be taken. Every morsel matters. Down here in the depths where hunger is constant, the dragonfish wastes nothing. But its teeth aren't the only trick it has. The dragonfish is a master of stealth and deception. Along its body are tiny glowing photophores, organs that produce bioluminescent light. These are used to attract prey, signal mates, or blend in with the faint residual glow of the water above through a process called counter-illumination. When viewed from below, the light masks the fish's outline, making it nearly impossible to see. In essence, the dragonfish becomes a ghost, a presence without a shape. Its most iconic feature, however, is the luminous barbel, a thin whisker-like filament that dangles from its chin like a fishing line. At the tip of this barbel is a glowing lure, which the dragonfish can wave or pulse like a small beacon. In the darkness of the trench, this light is hypnotic. Small animals are drawn to it, mistaking it for food or a path to safety. But as they approach, the dragonfish waits in stillness, and when the moment is right, it strikes. The speed of the attack is breathtaking. In a single instant, the dragonfish launches forward, jaws unhinging, teeth flashing, body twisting in a burst of motion. And then, silence. The prey is gone, swallowed into the shadows, and the dragonfish resumes its quiet glide, waiting once more. One of the most remarkable aspects of the dragonfish is its ability to produce red light, a rarity in the deep ocean. Most bioluminescent creatures emit blue or green light, as these colours travel farthest through water. But the dragonfish is different. It has evolved special light organs that emit red wavelengths and equally rare eyes that can see it. This gives the dragonfish an extraordinary advantage. It can see without being seen. In a world where no other creature can detect red light, the dragonfish's glow becomes invisible to others, like wearing night vision goggles in the dark. With this secret light, it can hunt, signal, and navigate in a way no other creature in the deep can match. It's a silent language, a hidden code, known only to those who possess the key. Even the dragonfish's skin is adapted for stealth. Some species have ultra-black pigmentation, a natural covering so efficient at absorbing light that it reflects almost nothing. This helps them remain unseen even when illuminated by artificial lights, such as those from submersibles or research equipment. In photographs, these fish often appear as floating mouths and glowing lures, with the rest of their bodies fading into the void. They are the perfect fusion of function and fear, designed not for beauty, but for survival in the harshest environment on Earth. And yet there is a certain beauty to them, not in the traditional sense, but in the poetry of their purpose. Every part of the dragonfish exists for a reason. Every adaptation tells a story of pressure, hunger, patience, and time. They are not monsters. They are the result of millions of years of quiet evolution shaped by darkness, perfected by necessity. Very little is known about their reproduction. It is believed that the females are much larger than the males, and that mating may involve complex signalling through light. Once fertilized, the eggs likely drift upward through the water, where the young develop in slightly less extreme conditions. As they mature, they descend, drawn ever downward into the quiet trench to take up their place among the hunters of the deep. To see a dragonfish in its natural habitat is to witness a vision out of a dream or a myth. Floating alone in the dark, its body barely visible, its lure pulsing softly like a candle flame underwater, it seems both real and unreal, a creature from another time, another world, and yet it is here, in our world, in our ocean. It reminds us that the Earth still holds secrets, still whispers stories in the language of light and silence, in the slow dance of predators that do not roar but glide. The dragonfish does not live in our sight, it lives in our wonder, and as we drift deeper into the trench we are humbled. We are guests in a kingdom ruled by shadows, a place where beauty is built on silence and light is a predator's promise. In the silent, inky depths of the Mariana Trench, where the weight of the ocean presses down with unimaginable force and darkness reigns unbroken, there drifts a creature so graceful, so surreal, that it seems to pulse with the rhythm of the sea itself. This is the abyssal deluge jellyfish, a creature of delicate threads and glowing veils, a living lantern floating slowly through a world without light. Unlike the colourful jellyfish that drift near the surface, basking in the sunlit shallows, the abyssal jellyfish is built for silence. Its body is soft and ethereal, composed mostly of water, like a ghost, moulded from the sea itself. It has no bones, no blood, and no brain as we know it, and yet it moves with such quiet purpose that one might believe it were thinking, dreaming, or listening to the deep. Its bell, often nearly transparent, pulses gently with every movement, expanding and contracting like a heartbeat. Each slow pulse propels it forward in a slow, drifting dance, as if it were breathing in the sea. Around the rim of its bell, long, trailing tentacles hang down in elegant curtains, some lined with glowing points of bioluminescence. These threads can stretch for meters, glimmering softly in the dark as they sway like underwater lace. And it is in these tendrils that the jellyfish hides its sting. Laced with specialized cells called cnidocytes, these tentacles are both beautiful and deadly. When prey brushes against them, a small fish, a drifting amphipod, a bit of organic debris, the cells fire tiny harpoons, injecting venom and ensnaring the creature in an invisible trap. The tentacles then slowly reel in the meal, bringing it to the jellyfish's mouth, a simple opening beneath its bell where digestion begins. But there is no violence here, no rush. Everything in the trench happens slowly. The prey does not struggle, and the jellyfish does not chase. It simply waits, suspended in the deep, letting the ocean bring its food. It is the essence of patience, of calm, a floating stillness that knows the sea will always provide her eventually. Some species of abyssal jellyfish produce their own light, faint pulses of blue or green created through bioluminescence. This glow may serve many purposes: to confuse predators, to attract prey, or even to communicate in a wordless language of flashes and flickers. In a world without sound or sight, this light becomes voice, gesture, and signal all in one. One of the most mesmerizing of these jellyfish is Deepstaria enigmatica, a rare species observed in the Hadal depths. Its bell is not shaped like an umbrella, but more like a flowing sheet, wide, transparent, and undulating like fabric in water. When disturbed, it curls in on itself, twisting and folding in a mesmerizing dance. Its internal structure is so sparse that it appears almost empty, like a ghost made of breath. Another species, known as Stygiomedusa gigantea, can grow to the size of a human, with thick, ribbon-like arms that drift below it like slow-moving wings. This jellyfish has no stinging tentacles. Instead, it uses its long arms to ensnare prey, wrapping around it and bringing it inward. It has only been seen a handful of times, each sighting, like a glimpse into a dream, rare, fleeting, unforgettable. These jellyfish do not swim quickly, nor do they control their direction with precision. Instead, they surrender to the currents, letting the sea carry them where it will. They drift through the darkness, serene and undisturbed, their gentle movement guided more by the breath of the ocean than by any internal will. In doing so, they teach us something profound, that surrender can be beautiful, that sometimes there is strength in letting go. Despite their apparent simplicity, jellyfish are ancient. Their lineage stretches back over 500 million years, long before dinosaurs, before trees, before even fish as we know them. In many ways, they are some of Earth's oldest survivors. Unchanged in their basic form, they have floated through every mass extinction, every planetary shift. And now, in the depths of the trench, they continue, unhurried, undisturbed, eternal. Their transparency serves a purpose. In the deep, anything visible becomes a target. By being nearly invisible, they avoid detection. Their bodies blend with the blackness. Their glow, when it appears, is soft enough not to betray them. A brief flicker, then gone. They are light and shadow in equal measure. Watching an abyssal jellyfish drift by a submersible's camera is a moment of awe. No matter how many times scientists see it, the sight never becomes ordinary. The way the bell ripples, the way the tendrils sway, the slow ballet of a creature that exists in a place no human has ever touched. It is a reminder that beauty exists beyond our reach, beyond our understanding, and often beyond our sight. In the surface world, jellyfish are sometimes considered pests, but in the deep they are revered, not by humans perhaps, but by the ocean itself. It cradles them, carries them, and in return they light its darkness. They are both decoration and function, dancers and predators, artists and survivors. And so as we drift through the Mariana Trench, surrounded by silence and weight and shadow, we pass beside them, the abyssal jellyfish, floating like dreams beneath the sea. They do not see us, they do not fear us. They have existed long before we arrived, and they will likely exist long after we are gone. In their quiet glow we see a glimpse of eternity, soft, slow, and impossibly still. In the blackest reaches of the deep ocean, where the weight of the water could crush a submarine and sunlight has never dared to reach, lurks one of the most iconic and haunting creatures of the abyss, the deep-sea anglerfish. It is a creature of paradox, grotesque and graceful, terrifying and fragile, monstrous in appearance but perfectly adapted for the quiet rules of the trench. The anglerfish has become famous for its appearance. A wide, gaping mouth filled with translucent, dagger-like teeth, eyes that seem to peer into nothingness, and most distinctively, a glowing lure that extends from its forehead like a tiny fishing pole. This lure, known as the esker, pulses with eerie bioluminescence, a self-made light in a world where no natural light exists. In the crushing stillness of the trench, it is this little lantern that becomes its most powerful tool, for hunting, for surviving, for thriving in the void. The anglerfish's body is compact and lumpy, covered in tough, leathery skin. Its coloration ranges from dark brown to deep black, allowing it to vanish into the surrounding darkness. But this drab appearance hides a remarkable set of adaptations. The mouth, large and upturned, can unhinge to swallow prey nearly twice the size of the anglerfish itself. Its stomach, soft and expandable, stretches to accommodate sudden, rare meals. In the trench, where food is not only scarce but often unpredictable, this ability is nothing short of vital. It doesn't chase, it doesn't race, it waits. The anglerfish is the very embodiment of patience. It suspends itself in the water column or nestles close to the ocean floor, completely still, while its glowing lure sways gently in the currents. To smaller fish, crustaceans or squid, this light looks like a curious flicker, perhaps a plankton bloom, or the gentle shimmer of a passing school. Drawn by instinct, by hunger or by confusion, they approach, just close enough, and in an instant the anglerfish strikes. Its jaws snap shut with lightning speed. The teeth, angled inward like glassy spears, ensure that once the prey enters the mouth, there is no escape. It is swallowed whole, consumed quickly, the glow of the lure blinking once more before returning to its steady pulse. The ocean grows quiet again. The anglerfish resumes its stillness. But this hunting method, while effective, is only one piece of its story. The most astonishing and surreal aspect of the anglerfish lies in its reproductive strategy. In many species of deep-sea anglerfish, the female is enormous compared to the male. While she may reach the size of a grapefruit, the male is tiny, sometimes no larger than a grape. He has no lure, no great jaws, no hunting tools. His purpose is singular: to find a mate. In the vast, featureless darkness of the trench, this task is nearly impossible. Males are born with highly developed olfactory organs that allow them to detect the chemical scent of a female from extraordinary distances. When he finally finds her, he bites into her flesh, not to harm, but to fuse. Over time, his body merges with hers. His tissues connect. His circulatory system links with hers. He becomes a part of her body, a living, breathing extension, whose only remaining function is to provide sperm when she is ready to reproduce. Some females carry several of these males fused to their bodies, tiny permanent companions, reduced to mere organs of reproduction. It is one of the most extreme examples of symbiosis in the natural world. To our minds it may seem alien, even unsettling, but to the anglerfish it is a brilliant solution to a fundamental problem: how to find another of your kind in an environment where the distance between individuals may be measured in miles. And so, in the dark, the female anglerfish glides, her lure glowing gently, her tiny mates fused to her body, her world one of stillness, hunger, and rare moments of opportunity. Everything about the anglerfish speaks of the trench. It is not made for speed, for beauty, or for the shallow world rules of life. It is a creature of waiting, of stealth, of quiet survival. It doesn't need colour. It doesn't need noise. It needs only the silence, the dark, and the rare miracle of something swimming too close. Despite its frightening appearance, the anglerfish is not a villain. It is not cruel or monstrous. It is a survivor. It lives in a place that seems, to us, unlivable. And it has done so for millions of years. Long before the first humans looked up at the stars, the anglerfish was down here, drifting, glowing, waiting. Its existence reminds us that nature does not care about our sense of what is normal or beautiful. It adapts, evolves, and flourishes in ways we may never fully understand. It whispers that survival in the end is not about power or speed or light. It is about finding a way to live, even when everything around you suggests that life is impossible. And so, as we float deeper into the trench, we imagine the anglerfish below us, suspended like a shadow, its lure glowing like a tiny star, its jaws quiet, ready. It is not waiting for us, nor does it need to be seen, but for just a moment we see it. And in that moment we understand the deep sea is not empty. It is full of strange light, silent grace, and lives more resilient than we ever imagined. In the deepest layers of the ocean, where darkness is absolute and silence stretches endlessly, some creatures begin to defy our expectations in yet another extraordinary way. They grow large, unnaturally large, despite the scarcity of resources and the extreme conditions that surround them. This mysterious phenomenon is known as deep-sea gigantism, and in the chilling, crushing black of the Mariana Trench, it gives rise to creatures that seem drawn from myth rather than biology. But what is deep-sea gigantism? It is the tendency for certain species of invertebrates and cold-blooded animals to grow significantly larger in the deep ocean than their shallow water relatives. Down here in the Hadal depths, where food is rare and temperatures hover just above freezing, this biological puzzle unfolds quietly. Giant amphipods, massive sea spiders, oversized isopods, and bizarrely long worms drift, crawl, or burrow through the soft mud, moving with the slow certainty of ancient life. They are not monsters, though they may look like it. They are simply the deep's quiet giants. Take the giant isopod, for example. Related to the tiny pillbugs we see on land, the deep-sea isopod is an armoured scavenger that can grow up to 1/2 metre long. Its hard exoskeleton is segmented like a medieval suit of armour, and its long antennae sweep the ocean floor as it lumbers slowly in search of carrion. With large compound eyes and strong mandibles, it can pick apart the remains of fallen whales, fish, or squid feeding slowly over many hours. These creatures are not aggressive. They are patient. Their metabolism is incredibly slow and they can survive without food for weeks or even months at a time. In one documented case, a captive isopod refused to eat for 5 years and lived. But why does gigantism happen here? Scientists believe several factors may contribute. The cold temperatures of the trench slow down metabolic processes, which in turn slows growth, but also prolongs lifespan. Animals here may take decades to reach maturity, and during that time they continue to grow. The pressure is another factor, intense and ever-present. It may influence the way cells divide and how bodies develop, but perhaps the most compelling reason is isolation. In the trench, life is scarce, and the creatures that do exist face little competition and few predators. With fewer threats and less need for speed, some animals can afford to grow large, take their time, and adopt strategies of endurance rather than escape. There is also something deeply poetic about this. In a place where energy is precious, and death can drift down like snow from the world above, size becomes a strength not of aggression, but of stability. Larger bodies can store more energy, endure longer fasts, and survive in a harsh environment where a single meal may be the difference between life and death. Some of the most enigmatic trench dwellers are giant amphipods. These shrimp-like creatures are usually tiny in shallow waters, but in the Hadal zone they can reach lengths of over 30 centimeters. Their exoskeletons shimmer with a pale translucence, and their legs ripple rhythmically as they swim, guided by chemical cues and the faint vibrations of the water. They are scavengers too, delicately dismantling the remains of anything that makes the long fall to the trench floor. In this way, they are part of a quiet cleanup crew, removing decay and returning nutrients to the sediment where microbial life will continue the cycle. Giant worms too drift through this world. Some species live in the mud, extending long segmented bodies into the soft earth to filter organic particles. Others hang vertically in the water column, extending luminous, feathery appendages to capture drifting marine snow. There is even a species known to build mucus tubes on the seafloor, structures that look like miniature castles made of silk and mud, through which the worm flows like a liquid ribbon. These creatures may be a meter long, but they move with such grace and softness that they seem weightless, unbothered by the darkness. Among the most startling of these giants are the sea spiders. Not true spiders, but distant relatives. These creatures have impossibly long legs and tiny flattened bodies. They walk slowly across the ocean floor, their limbs moving like stilts in slow motion, their mouths probing the soft corals and sea anemones that manage to cling to rocky outcroppings in the trench. In shallower waters, sea spiders are modest in size, but in the deep their legs can stretch across the span of a dinner plate, moving them effortlessly across the uneven terrain. What these creatures all have in common is silence. They do not charge or chase, they glide, crawl and hover. They exist not for our observation, not for drama or display, but for the ancient rhythm of survival. Their presence is a testament to time, patience, and adaptability. They have not been rushed into being. They are the result of millions of years of slow change, refined by the cold and shaped by the pressure. Even when scientists send down deep-diving submersibles to observe these giants, the creatures do not react with panic. They continue moving undisturbed, as if the lights and machines of humans are just another brief curiosity in their endless night. To witness them is to feel small, not just in body but in time. These animals belong to a world older than us, and likely one that will outlast us. Deep-sea gigantism is not an oddity. It is an answer, a solution to a question only the ocean can ask. How do you endure in a place where there is almost nothing? The answer: you become something more. Larger, slower, stronger, more still. You do not race the clock, you forget it exists. You let the current move you, you drift when there is nothing else to do, and in doing so you become a quiet monument to the power of adaptation. So as we drift deeper still, let us not look for monsters or legends. Let us look for giants, giants who do not roar, who do not tower in anger, but who live with dignity in the silence beneath the weight of the sea. Giants who remind us that sometimes in the stillest places of the world, life grows large simply by being patient. In the deepest corners of the Mariana Trench, far beyond the reach of sunlight, and far below the places where most human eyes have ever dared to look, there exists a realm of shadows and silence where even now, mystery continues to thrive. Here, in this alien abyss, lie whispers of life we cannot name, creatures that drift just out of reach of our knowledge, unseen by cameras, uncaptured by nets, and yet undeniably alive. This chapter of the Trenches story is not about what we know, it is about what we almost know, about the flickers of movement caught on camera for just a moment, about the unidentified blurs in the distance, about the faint impressions in the seafloor mud that suggest something large once passed by, even though no known creature matches its shape. It is about the tales of the unknown, those soft, silent hints that the trench holds more secrets than we can imagine. Even the most advanced submersibles can only explore for short periods. They descend slowly and cautiously, inching their way into the darkness, navigating with precision, but limited in reach. When they return, they often bring back footage of known creatures, snailfish, amphipods, jellyfish, but now and then there are anomalies, unexplained flashes of movement, shadows that shift against the ocean floor, eyes that shine for a second and vanish, shapes that don't match anything in our databases, and for each of these encounters, there's a question left behind. What was that? Marine biologists, ever cautious, label such sightings with neutral names: unidentified deep pelagic organism, or potential hadal fish. But the truth is far more exciting than the labels. These are not just glitches in the data, they are glimpses into a living library that hasn't yet been catalogued. They are the living unknown. Some creatures are seen only once, then never again. In one case, a remote-operated vehicle descending into a trench off the coast of Japan recorded a long, ribbon-like creature gliding just beyond the lights. It had no visible fins, no known anatomical landmarks, and its skin shimmered like oil in water. It moved slowly and deliberately, its body undulating in a way unlike any known fish or invertebrate. The footage lasted less than 20 seconds, but it sent waves of curiosity through the scientific community. Was it a new species, a survivor of an ancient lineage thought long extinct, or just a trick of light and angle? No one knows. It has never been seen again. Then there are the sounds. Even in the quiet of the trench, strange sounds are sometimes recorded. Low moaning hums, repeating clicks, metallic tapping noises that echo faintly through the water. Hydrophones, underwater microphones used by researchers, have captured some of these mysterious noises, but no one has been able to trace them to a source. Some scientists suspect they may be produced by unknown species of squid or fish. Others wonder if they're the distant echoes of geological activity. But in the absence of clear explanations, these sounds remain unsolved, lingering in the dark like the song of a creature just beyond the edge of our understanding. There is a special kind of wonder that comes from knowing that something is out there, even if you can't see it clearly. In the Mariana Trench, that wonder takes form in the thousands, perhaps millions of species yet to be discovered. The deep ocean is estimated to contain an astonishing number of unknown organisms. For every strange fish or glowing worm we've identified, there may be dozens more that remain hidden, tucked into the crevices of hadal cliffs, buried in the soft silt or floating unseen through the water like ghosts. Some scientists believe that the deep sea may harbour creatures that change our very definitions of life. Organisms that metabolize in ways we don't yet understand. Creatures that may have no eyes, no mouths, or perhaps no cells structured like those in the organisms we're used to. In the crushing depths of the trench, evolution has been free to experiment. shaping life not according to surface rules, but according to the physics of pressure, the chemistry of methane, the cold logic of total darkness. It is possible that the trench hides beings older than humanity, older even than the continents themselves. Life that evolved in total isolation, unshaped by sunlight, by predators, by anything we would recognize. If such life exists, it may be so different from our expectations that we fail to recognize it for what it is. We may look directly at it and not understand. It may not swim or drift or glow, but simply be, resting silently on a rock, or moving so slowly that we mistake it for stone. Even the sediment tells stories. Researchers have found strange biochemical signatures in the mud, patterns of enzymes and metabolic byproducts that suggest microbial life forms that function differently than anything seen in other parts of the ocean. These microscopic clues whisper of ecosystems we've never mapped. Food webs built not on sunlight, but on hydrogen, on sulfur, on processes that belong more to alien worlds than to Earth's surface. And then there are the legends, the quiet, almost forgotten stories passed along by sailors and deep-sea explorers, of creatures with glowing rings and long trailing limbs, of shadows that seem to follow submarines without ever being caught on camera, of sudden pressure changes or unexplained turbulence in otherwise calm space and depths. Though many of these stories remain unconfirmed, they hint at the possibility that there is more happening in the depths than we can measure with machines. The Mariana Trench is a living riddle, a place where known science ends and the unknown begins. It humbles us. It reminds us that for all our knowledge, we have only dipped our toes into the ocean's true vastness. The unknown is not a blank space. It is filled with life, just not life we fully recognize yet. And that is perhaps the most comforting thing of all, that in the quiet dark, in the deepest and loneliest place on earth, something still stirs, something strange, something new, something that waits, not to be caught, but simply to be noticed. And one day, perhaps we will. Far beneath the surface of the sea, past the sunlight and twilight zones, down through the black stillness of the abyss, lies a realm so extreme, so unfamiliar, that every breath of life is a miracle. In this Hadal world at the very bottom of the Mariana Trench, there is no grass, no trees, no reefs, and certainly no sunshine. Yet even here, life endures. And at the very core of that endurance lies one essential question. What do these creatures eat? In a world where no plants can grow, where no photosynthesis can occur, where even light itself cannot reach, the idea of a food chain seems almost impossible. But like everything in the deep, the answer is stranger and more beautiful than we might expect. The most common source of food in the trench is what scientists call marine snow. This is not snow as we know it, falling in flakes from clouds above, but a slow, steady drizzle of organic material drifting downward from the upper layers of the ocean, bits of dead plankton, the remains of jellyfish, fish scales, fecal matter, and tiny fragments of decomposing plants and animals all clump together and begin their long, gentle fall through the water column. It can take weeks for these particles to reach the bottom. As they drift, they are slowly consumed by organisms along the way, broken down, digested, reabsorbed, and then released again into the water to continue the cycle. By the time the marine snow reaches the trench floor, it is a fine dusting of nutrients, barely enough, and yet just enough for life to continue. Many of the creatures that dwell on or just above the trench floor are detritivores, organisms that feed on decaying material. Amphipods scurry across the soft mud, gathering specks of organic matter, like careful housekeepers. Sea cucumbers, shaped like slow-moving slugs, sift through the sediment, digesting what little nutrition remains in the fine particles. Some worms build burrows and reach upward with feathery tentacles to trap these floating bits before they even touch the ground. It is a world built on efficiency. Nothing is wasted, everything is used. But marine snow alone is not always enough. Sometimes larger, more dramatic meals descend from above, what scientists call fall events. A dead whale, a giant squid, or even a large fish can become a sudden, enormous windfall for the trench ecosystem. When a whale dies near the surface and begins its descent, it becomes a slow-moving banquet. As it sinks, it is gradually stripped by sharks, scavengers, and microorganisms. By the time it reaches the Hadal depths, the skeleton may still carry enough flesh and fat to nourish the trench floor for years. The arrival of a whalefall triggers a burst of activity. Amphipods swarm, giant isopods lumber toward the scene, hagfish wriggle into the carcass. Some species of worms even specialize in feeding on whale bones, drilling into the marrow with acid-secreting mouths. The remains of one whale can support an entire micro-ecosystem for decades, an island of nourishment in an otherwise nutrient-starved desert. But not all trench life depends on what falls from above. Some organisms rely instead on the Earth itself. At certain points along the trench, geochemical activity causes fluids rich in hydrogen, methane, and other compounds to seep from cracks in the seafloor. These areas, known as cold seeps, become hubs of a different kind of life. Life that feeds not on sunlight or rain, but on chemistry. Here, bacteria thrive that can metabolize these compounds into energy through a process called chemosynthesis. Unlike photosynthesis, which uses light to produce sugars, chemosynthesis uses chemical reactions to fuel life. These bacteria form the base of a unique food chain, one that can support clams, tube worms, and other animals that live in symbiosis with the microbes. The worms and clams provide a stable home and a source of nutrients. The bacteria, in turn, generate food. It is a partnership so complete that some of these creatures have no mouths or stomachs of their own. They rely entirely on the bacteria within them. Elsewhere in the trench, predation still plays a role. Larger fish like the Hadal snailfish prey on smaller amphipods and crustaceans. The dragonfish uses its bioluminescent lure to draw in unsuspecting prey. Cusk eels drift along the bottom, scanning for movement and swallowing small creatures whole. Even in the depths, the hunt continues, quietly, slowly, in bursts of motion followed by long, watchful stillness. The energy that drives the trench ecosystem is meagre by surface standards. There are no vast pastures of plankton, no quick blooms of algae. Instead, everything moves at a different pace. Energy is stored, not spent. Movement is deliberate, not impulsive. Feeding may be rare, but when it happens, it is precise and complete. Trench creatures do not snack. They survive. Some scientists believe that the creatures of the Mariana Trench have evolved the ability to detect food sources from kilometers away, using chemical cues that drift through the water like invisible scent trails. Others may sense the vibrations of a carcass hitting the seafloor from hundreds of meters above. In the deep, your best chance at eating is often determined by how quickly and how quietly you can find the next opportunity. There is also a kind of community in the way food is shared. When a large carcass falls, many species gather: scavengers, predators, microbes. They do not compete in the loud, aggressive ways of surface predators. Instead, they come in waves. Small animals feed first, then the larger ones, then the specialists. Over time, even the bones are colonized by microbes. Nothing is left, nothing is wasted. To survive in the trench is to be resourceful, to live on less, to find nourishment in what others would overlook. The creatures here do not feast often, but when they do so with quiet reverence for the moment. And when they are not feeding, they wait, still, patient, suspended in the dark. And so, in the black depths of the Mariana Trench, the question of what these creatures eat becomes something more. it becomes a lesson about patience, about adaptability, about making life possible where it should not be. And perhaps in their quiet foraging, their slow drifting, and their utter devotion to survival, the creatures of the deep teach us something not only about hunger, but about hope. In the deepest recesses of the Mariana Trench, where the pressure is unimaginably intense and the cold bites through even the toughest skin, human eyes have only recently begun to glimpse the secrets of life. It is a world so remote, so alien, that for much of human history it was believed to be barren. But now we know the truth. The trench is alive. It is filled with creatures that glow, creep, float, and thrive where no light shines. And yet, perhaps the most important question we can ask is not what lives there, but how do we know? Exploring the Mariana Trench is one of the most challenging scientific endeavours on Earth. At nearly 11,000 metres deep, it lies far beyond the reach of scuba divers, submarines, or remotely operated vehicles used in most ocean research. The pressure at these depths exceeds 1,000 times the pressure at sea level, enough to crush human-built structures if they are not precisely engineered to withstand it. The temperature hovers just above freezing, and the darkness is absolute. To study this mysterious place, scientists rely on technology that seems more like space exploration than marine biology. Specialized deep-sea submersibles, robotic explorers, and pressure-resistant sensors are designed and tested over years before they make their descent. Each dive into the trench is an act of courage and precision, and each moment spent there is precious. One of the most groundbreaking vehicles to explore the trench was the DSV limiting factor, a submersible capable of descending repeatedly to the very bottom of the ocean. Built with an advanced titanium pressure sphere, this vessel could carry a human pilot to the Challenger Deep and back over and over, a feat never before achieved. Thanks to its journeys, we've received some of the clearest images and high-definition video ever captured from the ocean's deepest point. Earlier in history, in 1860, the bathyscaphe Trieste made the first manned descent to the bottom of the Mariana Trench. Swiss oceanographer Jacques Piccard and US Navy Lieutenant Don Walsh spent nearly 5 hours descending through the water column. When they finally reached the bottom, they saw something astonishing, a living fish. It was a flat creature, possibly a type of snailfish, drifting slowly along the seafloor. This single sighting shattered the long-standing belief that life could not exist in the crushing blackness of the Hadal Zone. Since then, robotic explorers have taken on most of the trench's investigations. Remotely operated vehicles, ROVs, can descend to incredible depths and be controlled by scientists aboard research vessels floating high above. These robots are equipped with high-definition cameras, mechanical arms for sampling, and sensors that can measure salinity, temperature, pH, oxygen levels, and pressure. They gently hover just above the seafloor, capturing footage of glowing jellyfish, strange crustaceans, and the slow movement of giant worms. Every moment of footage they send back is studied, replayed, and analysed, frame by frame, as if it were a message from another world. Autonomous underwater vehicles, AUVs, go one step further. These intelligent robots are programmed to explore without direct human control. Once released into the ocean, they descend on their own, mapping terrain, recording video, and collecting samples. One such vehicle, Nereus, reached the Challenger Deep in 2009. Tragically, it was lost in 2014 when the immense pressure crushed its frame. Even our best machines are vulnerable to the extremes of the trench. Every expedition is a gamble. Every discovery carries a cost. To collect physical samples from the trench, researchers use specially designed traps and sediment corers. These instruments are dropped overboard and slowly sink to the seafloor, where they lie in wait. Some carry bait to attract scavengers. Others are designed to scoop up layers of sediment and preserve them under pressure. Once retrieved, these samples are brought to specially controlled labs where scientists can analyze the life within: microscopic organisms, strange isotopes, fragments of shells or exoskeletons, and sometimes entirely new species. But even bringing samples to the surface poses a problem. Many of the creatures that live in the trench are so finely tuned to the pressure that when they are brought up, they collapse or disintegrate. Their soft bodies, adapted for life in the crushing deep, cannot survive the relative freedom of sea level. This is why so much of what we know about these animals comes not from physical examination, but from footage, fleeting images of living beings captured in their natural undisturbed state. Because of this, scientists have also developed pressure-retaining chambers. These devices allow live samples to be brought to the surface without losing the intense pressure they need to survive. Using these chambers, researchers have been able to keep some deep-sea creatures alive for hours or even days, observing their behavior, their feeding patterns, and their biology in ways never possible before. There is also a wealth of invisible data being gathered: chemical signatures in the water, microbial DNA sequences extracted from mud, isotopic clues about the origins of organic matter. These traces tell stories that cameras cannot: how bacteria survive in the absence of sunlight, how methane seeps create localized ecosystems, how ancient carbon moves through the food chain. Through this invisible language, the trench speaks of processes that have gone on for millions of years, far from human eyes. The deep-sea community is made up of scientists from many disciplines: marine biologists, geologists, engineers, chemists, geneticists, and even philosophers. They all come together to ask the same question: what is this place? And each expedition adds a fragment to the answer. Every descent into the trench reveals more complexity, more diversity, more wonder than we expected. Sometimes what's found is not life, but a reflection of humanity. Fragments of plastic, synthetic fibers, and pollutants that have somehow drifted down to the very bottom of the world. These discoveries are sobering reminders that no part of the Earth is untouched by our presence. They also challenge scientists to ask not only what lies there, but what are we doing to protect it? In the end, exploring the Mariana Trench is more than a technical achievement. It is a journey of humility. It reminds us that our planet still holds mysteries deeper than our dreams, that there are places where time moves differently, where life follows ancient laws, and where the Earth continues to shape itself in secret. And so, from the quiet hum of a submersible descending into blackness, to the careful study of a glowing fish caught on film, the story of how we study the trench is a story of reverence. We do not go there to conquer, we go to listen, to observe, to understand, and as long as the trench keeps its secrets, we will keep returning, drawn not by the need for answers, but by the beauty of the questions. As our journey through the Mariana Trench draws to a gentle close, we begin the slow, peaceful ascent back toward the surface. A return not rushed, but deliberate, like waking from a dream you don't want to end. We are leaving behind the crushing pressures and profound silence of the Hadal depths, ascending not only through layers of water, but through time, memory, and mystery. The return is not sudden. It unfolds gradually, just as the descent did, with each passing meter lifting us from darkness back into the world of light. As we drift upward, we retrace our path through the strange and wondrous zones of the deep ocean, each one holding its own secrets, its own rhythm, its own life. From the trench floor, we rise first through the Hadal zone, where the ocean still presses in like a mountain turned upside down, but where life lingers in patient stillness. Here, creatures like the ghostly snailfish, giant amphipods, and translucent cusk eels fade from view. Their world is one of permanence, of quiet that stretches beyond the reach of sound. we give them one last look, those ancient dwellers of the deep, and thank them for sharing a glimpse of their realm. A little higher we pass through the abyssal zone which stretches across much of the ocean floor. It is no less mysterious and no less silent. Here the water remains cold and black, and yet it teems with life. Slow-moving, luminous, strange. The dragonfish floats below us, vanishing into darkness with its silent glowing lure. Jellyfish drift like dreams through the water, their tentacles glowing faintly as they pulse in slow rhythm. We are moving through a gallery of living art, a parade of forms shaped by evolution's softest hands. The pressure begins to ease imperceptibly at first. Our vessel, real or imagined, no longer groans with the burden of the deep. We are carried upward gently like a leaf rising in a slow current, with no destination other than the open sea above. As we continue, bioluminescent signals flash more frequently, tiny creatures sending out pulses of light in the vast dark. These brief, brilliant glows are like final farewells from the deep sea, reminders that light never truly vanishes, even in the darkest places. One last flicker here, another there, and then the glow recedes. Now we enter the bathypelagic zone, known also as the midnight zone. Here, no sunlight has ever reached, but the life around us becomes more familiar. Squid, deep-sea shrimp, and lanternfish flit through the water. Some of them, like us, are migrators, moving up and down through the ocean in this daily dance of survival. Their bodies are leaner, their movements more fluid. We are entering a world still shaped by mystery, but one that edges closer to the light. It is quiet, still, but not as still as the trench. The sea here has more motion, more energy. We begin to sense the slow stirring of currents, the faint pressure of movement, the quiet music of returning life. We pass into the mesopelagic zone, the twilight zone. Faint traces of light begin to reappear, not from the sun, but as a soft suggestion in the water. It is not yet daylight, but it is no longer darkness. The creatures here are caught in between, some designed for stealth, some for brightness, some for camouflage. Silver scales shimmer like starlight. Schools of fish drift in fluid coordination, each turning with the others like a single thought in motion. As we rise, the temperature warms slightly. The water becomes less dense, the weight on our shoulders begins to ease, and the world opens up around us. Shadows take on colour, shapes grow more defined. Somewhere far above, the sun continues to shine, though its rays still have a long way to travel before they touch us. And now, at last, we enter the epipelagic zone, the sunlit zone, the upper layer of the ocean where life bursts with energy and motion. Coral reefs, dolphins, swarming plankton, darting fish. The world here is fast, noisy and bright. And while it is beautiful, it feels almost overwhelming after the long, sacred stillness of the deep. The surface is just ahead, a glittering mirror that separates water from sky. We pause, just for a moment, beneath it, listening, remembering. Behind us lies a world unlike any other, a world of ancient giants, glowing whispers, and lives lived without light. A world so few will ever see, and yet one that continues every moment without our witness. We rise the final few meters and break the surface. Above us, the sky stretches wide and endless, blue or grey or golden, depending on the time and place. The wind is different. The air tastes sharp. The sounds of birds, waves, and distant life return all at once. But something in us has changed. We carry with us now the memory of the deep, a quietness, a sense of reverence, a new awareness that beneath this glittering sea lies a cathedral of darkness, where life endures in ways we barely understand. And though we have returned to the world of light, the journey lingers. The trench stays with us, in our imagination, in our wonder. in the knowledge that even in the most impossible places, life glows softly, waits patiently, and thrives without being seen. So rest now, traveller of the deep. Let your thoughts drift like jellyfish through the memory of darkness. Let the slow pulse of the ocean cradle your dreams, for though we have returned to the surface, part of you still floats down there, in the quiet, in the dark, where everything is still and everything is alive.